So question number 2 asks you to list 5 different factors that can influence protein stability during a purification procedure. Well, they're listed here. All right, pH, temperature, proteases, adsorption, and long-term storage. So pH, certain all of our proteins are going to be happiest at a certain pH value. All right, if you go to different pH values than that protein is usually found at, all right, you can basically start protonating or deprotonating amino acids that protein needs, and that can disrupt salt bridges, create new salt bridges, and as a result, the protein can lose its three-dimensional structure and become unstable. Temperature, high temperatures in general tend to denature proteins because the more heat we add into the system, the more energy, the more the protein starts to vibrate. And once it starts to vibrate a lot, all right, we can then open up the protein and cause it to lose its 3D structure. In addition, temperature also, no, I won't say. Never mind. All right, proteases. So these are enzymes that can degrade other proteins. So most organisms have proteases in them, which when we're purifying a protein, those protease enzymes are going to be present. So we have to deal with them either by adding in inhibitors or by quickly purifying our protein away from them. All right, adsorption. So lots of different surfaces like plastics, glass, for instance, they can bind protein. And so if you, for instance, are purifying a protein at really low concentrations, but you might come back the next day to find that your solution is devoid of protein. Why? Because it's all on the side of your glass beaker, or all on the side of your plastic, Falcon tube, for instance. So adsorption, which is basically the binding of a protein to a surface, this is something else we have to contend with. The last part here is long-term storage. Now, most protein purification procedures take multiple days. So we need to keep the protein cool during that time. So generally, purifications are carried out in a cold room or in a fridge type environment. But for very long-term storage, proteins actually have to be frozen. And in order to do so, they have to be frozen quickly, for instance, in liquid nitrogen, and stored at very, very cold temperatures like minus 80 degrees Celsius. In addition, with long-term storage, removing oxygen from the environment can help prevent disulfide bond formation, stuff like that. So these are all kind of concerns with long-term storage that you have to be aware of as well.